Today we're going to quickly cover the basics of doing source view trace in ZTPFGI, including, and we're going to use assembler as the example there, and we'll talk about using a source view trace. Along the way, I'll try to talk about a feature for controlling and using source view that you may not be aware of. It might come in handy. And then we're going to spend time on discussing and demonstrating source view for SabreTalk support in source view. So to start with, you can see that I'm connected to a system. I've got my load sets view showing. The load sets view is where you go to add things to source view trace, add members, programs to source view trace. I've got, several things in here, things that I've added, load sets I've added myself. It's got the load set level, the SO level, and then the member level. I've also got things that I've added just from the system, and when we're going to demonstrate assembler using a couple of those. So there's several ways to get things, we call it locking, but to lock these things into source view trace. One is you can just double click. Since I've got two things I want to add to source view trace, I'm going to hold down the control key and multi-select and then right click and say trace in source view. And both of those things are added. You can see that now there's a lock button, icon next to the things in the load sets view, and there are little lock icons on the little locks on the icons for the editor tabs, and that shows that they're locked into source view trace also. Now, how do we stop in source view trace? Well, you want to capture the right ECB. You might open up one of our trace resource terminals, ALC1 or LOC1, and enter a transaction, and that will stop. That will stop in that program. Or you might use async resource, and your company undoubtedly has asynchronous resources of different kinds set up, so that you could capture an ECB in a different way. Well, it might be coming in from the web or something. Because we've got a test program here, it's a demonstration. We're going to enter very directly with a create ECB. We're just going to create an ECB to enter this TST5 program. And there we are stopped. Now you can see that the screen has undergone a change. We've entered what we call debug layout, and that's just a different arrangement of views and editors that's specialized for source view. Up here, the debug tab is showing, and the debug tab, you can think of it as your source view tab. It lets you control what happens in source view. So, for example, we've got these buttons that you can show the variables, the watches, the call stack, and everything. So if you happen to come over here and you don't want to see the watches for a while, you could close it. It's perfectly fine. You just come back to this button and you can show it again. No problem. This shows if you've got multiple ECBs, this drop-down will show what those are, and it'll also allow you to switch between the ECBs to edit a different ECB. Also, clicking it will display the current ECB if you want to, and so you can see the registers and so forth. Normally, you don't have to come up here to see the registers because you can see them in the variables view in source view. And then, and this will let you switch to active terminal. The step into button, it usually goes to the next statement, but if you're on a, it will also let you step into a subroutine. Step through usually goes to the next statement, but if you're on a statement line, which will a BAS that will go into a subroutine, it will execute that subroutine, but it won't step into the program, into that subroutine and stop in it. it'll just let you keep going in the straight line flow that you're on. Step out will let you step out from, if one program is called another, and we can actually demonstrate that here in our example today. You can step out to the calling program. Exit ECB will exit the current ECB that's you're currently debugging. Exit all ECBs will exit all of them. And run no trace is useful when you've seen everything you want to see and you just want to get out and you want to maybe work on your program some. You can click run no trace, and that will ignore any breakpoints or any trace that you have set up, and will just go directly to finish the program. Reset terminal is a little drastic. That's if something is really wrong. You can reset the terminal normally. You don't want to do that. And I'll just mention machine trace also. If you click that, you can see information at the instruction level down here in this window if you as you step through. So I'll close that. So regarding these views down here that we can see, obviously let's start with the gutter over here. The blue dots show you where you can set breakpoints. You just click to set, click to remove, and the variables view in Assembler, it shows you the registers first of all, and if there's any using for that register, it will put the name of the dsect next to it, and if it does, that means that you can drop it down like a structure and see the fields of that dsect there. And then farther down in the variables view, you can see if there's any variables that we know that you've used in your program, we put them over here just for your convenience. So you could go directly to what EB0EB is currently pointing to and show that. Things turn red over here if they've changed, and you can edit values. If the rules of the core allow you to edit, you can come over here and edit. So I can put 100 there if I wanted to and hit enter, and it will change. I'm going to change that back to 0. And if it's a character that needs to be changed, you can surround it with a tick mark and say I want this to be a Q, and hit enter, and it will change that. And of course, the reason you want to do that is if you're trying to test something in particular and you need to patch a value in a variable in order to test a certain value, something like that. Let me go back to nothing at all there, and let's see. Okay, all right. So so we've stopped in source view. You can step and you can see things happen over here. The watches, I should mention the watches. If you've got a value here, you want to watch in particular, maybe it's not that convenient to drill down in the variables to see this field. You could right click it and say add watch at cursor. Then it will put the value over here. And you can also modify the value in the watches. You can also put dsects and structures over here if you need to look at that. I wanted to describe something which, as you're stepping through your program, and this is the thing that you may not be aware of that I was talking about. Every time you step, we update the variables in the watches. So sometimes when you're tracing through your program, you're not that interested every time in the variables and watches. Maybe you just want to get going, and so you want to step more quickly. One thing you can do is if you want to do that is you can close the variables and the watches, and then we don't update those. Let me just go back up here to give myself more room because this is a short program. Now I'm hitting I'm clicking F10 on my keyboard. You can see I can go through quickly. There's no variables or watches to update, and I can just quickly follow the branches and follow everything that's happening, and I can see where my program's going. Then when I want to see the variables and watches, I can bring those back up, and they're there. Now, something I wanted to tell you, this is a little out of the ordinary. I don't want to spend too long on this, but you can control the frequency that these things update with. That is the interval, the delay until they update, so that you can step more quickly and keep the variables open. And so you would go to the ZTPFGI options. Now this is, if you've got an older version of ZTPFGI, there's a round button up here you click. With the newer version, you click the File tab, come down to the ZTPFGI options, and if you go to Trace Behavior, we've got, this is for updating the variables, the watches, core windows, things like that. If you want them to update more quickly after you stop in an ECB, you'd move it over to the left side. If you want them to update less quickly after you stop in an ECB, you move it to the right. Now, why would you want it to update less quickly? It's so it gives you time to click the step button again, so that you can step without the update happening, and then you can step through more quickly. So if I move it way over here, that's going to give me a lot of time to step again, which just may work better with the way I'm working right now. A good place to leave it is in the middle. So that's it's not really how frequently it updates, it's the interval. So if you click the step button before it's updated, it won't update, it'll wait for you to step, then it will update finally after a certain interval. So that's probably as clear as mud, but if you have any questions about that, you can ask. Okay, so there is that feature, which you probably weren't aware of. Now, as far as, I'll just demonstrate, setting a breakpoint. I'm going to go back up here. Setting a breakpoint, you click the Run button to run to the breakpoint, and so forth. We're about to do a CRIM-C, start TST6. And now we're into TST6 here. You see we've stopped over here in TST6. If I keep clicking the step into or the step through, we'll continue here. If I click the step out, we'll go back. It's like a run until return. We'll do all this code, but we just won't stop at any of it, and we'll go back to TST5. So I'll do that, and see we're back in TST5. So that's a nice feature. Smart variable tooltips. So you don't necessarily need to go to the watches or the variables to see the values of your variables here. You can just hover over most of them and see the value. So that will come up as a tooltip. This will too, I think. Yep, and if it's a structure, it will have a little plus sign, and you'll be able to look at it that way. This is really the basics of using source view with assembler as an example. Let me show a different way to look at the source and step through it, which is the assembler listing. I'm going to run no trace. This will run the program to completion. And since I'm switching modes, I'm just going to go ahead and close these sources. If I go back over to the ZTPFGI options, very close to where we were before, trace behavior, source view trace, can say trace assembler using listing. This is a global setting. After you click this button, all the tracing of assembler that you do will be using the listing. So it's either look at everything using the listing or look at everything without the listing as you trace through it. So I'll click that. And then now if we just lock the programs in the same way we did before, I'm just going to open one of them. I'll double click it. You can see here now, normally of course I make my screen bigger, but for the demo I've made it lower resolution. You can see we've got the listing information here, and we can step through this in the same way. Stop in TST5. We're stopped, and you can step through, and now you've got the listing information to look at. This particular file that we provide here will always be read-only. The variables, the watches, the hovering, it all works exactly the same way in the listing. Okay, so that's the listing. I'll close that. I'm going to go, just in case I forget, I'm going to go back and set that back. Okay. So that's the basics of source view trace with assembler. How about SabreTalk? SabreTalk support really uses all the same views, and in fact it's got an extra view to support it, so you've got a very full support of SabreTalk here. Let me lock in a SabreTalk program into trace. You do it exactly the same way. So that's locked in. You see the lock button. Again, I'll just enter this program very simply with by creating an ECB in it, and we're stopped in the SabreTalk program. The SabreTalk support allows you to step at the statement level through SabreTalk. If we didn't have this support, of course you'd be stepping through at the assembler statement level rather than the SabreTalk statement level. In this support, you set the breakpoints the same way. All the variables that we show, all the variables are considered global to the SabreTalk program, and they're all displayed over here in the variables view. So in the variables view, you have the variables in the SabreTalk program, and then scrolling farther down, we do also put the registers like we do in assembly. So you can scroll down and see those. The variables are displayed in the variables view with the compiler, quote-unquote compiler rules for SabreTalk variables. So as you may know, you can write the variable obviously normally when you're creating your SabreTalk program, but the compiler sort of mangles the name a little bit and puts a dollar on the end of the variable name if it is shorter than 8 characters. If it's exactly 8 characters, it doesn't do that, as you can see here. So what we have in the variables view is what the compiler has given us. The compiler gives it to us with $signs. So that's what we show here. However, the ZTPFGI is smart enough to know to account for that in the source itself, so that we don't require you to have $signs over here. So you see you can hover, no need for a $sign. We understand, we automatically convert the name for you and show you the value. If I step here, we'll see the value change over here, and see you can hover, and the tooltip works here, and you can see, and it also works in the watches view. So if I right click here and say add watch and cursor, got bin 31 over here, no need for the $sign over here. Now, if you really love the $sign, you can type it and it's okay. The watches view understands both that. It's just the variables view that sort of has to have the dollars, because that's what the compiler gives us. Excuse me. So the types of variables we support. We support what we're calling regular variables. That's variables that are not structure or based pointer variables, and those have their names displayed in the with their value in the variables view. and you can put them in the watches view. So an example is, well, any of these things. We also support structure variables. So, and those are displayed as structures in the local variable display. So, an example of a structure variable, let's see, let's go down a little bit. It's probably passing some, but here's one here. So it's a structure, you know, you can see it's got these complex fields down here. And so this is displayed as a structure, and you can drill down and see the values. We also support structures with a based pointer. So an example of that being declared would be, let's see, right here, my based, my pointer. You can see that right there. So the way that's displayed in the variables view, it's displayed with the name of the pointer. So this my pointer is the value of that variable. If I run down, I'm going to run down to this breakpoint down here, and you see a lot of stuff is updated because the values have changed. And if you now that you know my pointer is based on that structure, so you can drop down my pointer as if it's a structure, and you can see what the structure that is pointing to, the fields of the structure it's pointing to there. You can also hover in the editor area itself, see my pointer, and then you've got a little plus, so you can hover over that, and you can see, you know, you can drill down into the structure that my pointer is pointing to. There are little used types that we just show, such as decimal type, that we just show as an array of characters. There's a few other things that we, maybe one other variable, little used type that we don't support, but we support those. So we hope that'll take care of most of the needs that you have there. Now, something we've introduced for SabreTalk, which we didn't have before, you could see the auto block before, but we've got a new view called the current auto view. You can open that up. It'll show the auto block of the current program, and it will apply a panel over that, which will allow you to see the values of the variables here. If you want, you can dock this somewhere and you can leave it open, or you can leave it floating, whatever you want to do. And this will update depending on what the current program is. And if you want to, you can come over here and you can edit values, hit enter, and it will change the value. So you could change the values this way too if you're more comfortable. This is a type of view we had in TPF-GI, which was our 4.1 product, TPF 4.1 product, and we believe some developers would still, might like this kind of view. So that's why we provide it. Okay, now, so this is the SabreTalk statement view of SabreTalk. If you prefer, I'm going to run no trace here. If you prefer, you can view SabreTalk in two other different ways. Go down to the ZTPF-GI options. Here's what we're doing. Currently we're tracing SabreTalk using SabreTalk source. You can also trace it using assembler source. So I'm going to close that, which also unlocks it, and I'm going to add it to source view again. And now we're seeing the assembler source instead of, we're seeing it at the assembler level. So let's enter that and step. You can see what this is this is a SabreTalk statement commented out, and then the one or more assembler statements and instructions and so forth that are required to implement the SabreTalk statement. Here you can see that the dollars are in the source. That's because that's what the compiler does. It adds the dollars in the assembler source. But ZTPF-GI is smart enough to account for the dollars, so if you hover over that, you'll still see the value in that Smart Variable tooltip. Also, you can see that the watches view, even in symbol mode here, understands without the dollar and with the dollar. And the last way you can view this is as a listing. I won't bother to show that right now. It looks exactly the same as we did it. It looks like this, but with the listing information in the left-hand columns of the source.